Hi, I'm Tuto Frank. Welcome again to today's class. Now today we'll be looking at an aspect of mathematics called calculus. So we're looking at calculus today. Now to begin with, I said calculus is a branch of mathematics that studies the relationship between changes in quantities or variables. So the aspect of mathematics that has to do with the relationship that exists between changes in quantities or variables is what we refer to as calculus. Now, the major branches of calculus are differentiation and integration. And for today's class, we'll be looking at the very first one, differentiation. So let's move on. Now, I said differentiation is a mathematical process that finds the rate of change, of a function with respect to one of its variables. All right, so a mathematical process that finds the rate of change of a function with respect to one of its variable is what we refer to as what? Differentiation. Now tell us if y and x, as an example, are related in a particular mathematical equation. For an example, that differentiation deals with the rate of change in y to change in x to the nearest approximation. Alright, so if I have a mathematical equation that involves x and y, and the rate of change of y with respect to x to the nearest approximation is what we refer to as what? The differentiation. Now, look at it here. I said differentiation is equal to change in y over change in x. Now, I said note, differentiation measures change and not the thing itself. So the key word I want you to take note of as we move on as subject matter of differentiation is that differentiation measures change, the rate of change of a function with respect to one of its variable. Now let's see an analogy here, a simple analogy. Now I said imagine you are driving a car. Now the speedometer shows the speed. Now that speed simply means the rate of change of the position of the vehicle. The rate of change of the position of the vehicle. So that differentiation helps to calculate the speed or the rate of change. So that rate of change of the position of the vehicle indicated by your speedometer is what we calculate for using the knowledge of differentiation. So that's why I said differentiation measures change and not the thing itself. So differentiation is not to measure the car, but differentiation is to measure the rate of change of the position of the car. I believe you got that. Now let's see some real world applications of differentiation. Why do we study application of the differentiation? How can it be applied in real world situations? Now, number one, I said in biology and in medicine. Now, the knowledge of differentiation is used to model growth and spread of diseases, and it's also used in pharmacokinetics to study drug absorption. Now, another application is in finance. Now, the knowledge of differentiation is also applied in finance to evaluate your return on investment. We can go on and on and on to state some major real-world applications in differentiation. But we're going to stop here and move on to the main subject matter, which is the types of differentiation, and then we're going to see how we can do some calculations involving differentiation. Follow me. Okay, now welcome back. Let's look at this method of differentiation. Now basically we have two methods employed in differentiation, and the first is the first principle, and then the second is your direct or your differentiation rule. Now for the sake of this class, I want to look at the second one, the direct or the differentiation rule. Now what do we mean by direct or differentiation rule? Now I said this method involves the use of established relationships between quantities. So we have established formulas, established relationships between quantities that we are going to employ in solving differentiation problems. Now let's look at the first one here. Now for algebraic function, now you can begin an algebraic function and ask to differentiate. Now what is the established relationship we employ for algebraic function? Now look at this. I said here we multiply the variable by the initial power. Take note of that. The initial power, and then reduce the original power by 1. by 1. So we multiply the variable by the initial power and then we reduce the original power by 1. Now, what do we mean by that? To drive home the point, look at this. So if y equals x raised to power n, now what's the initial power here? N. What's the variable? X. So you bring this initial power to multiply the variable. So n x, so n multiplying x, and then you reduce the initial power by 1. What do we mean to reduce by 1? Simply put minus 1, so n minus 1. So again, we multiply the variable by the initial power, so bring the n beside the x, the variable, to multiply the variable, so nx, then you reduce the initial power by 1, so n minus 1. Now let's take an example. Now if y equals 3t cubed plus 2t squared minus 7t plus 3, now find dy dt. Now what do you mean dy dt? Don't be confused. It simply means differentiate y with respect to t. Now remember I said in differentiation we are looking at the rate of change of a function with respect to one of its variable. In this case, the rate of change of the function y with respect to t. So dy dt, differentiate y with respect to t at t equals 1. Now how do we go about this? Now this is an algebraic function, so let's apply the relationship here. Now given that y equals 3t cubed plus 2t squared minus 7t plus 3. Now differentiating y with respect to t. Now please pay attention, I need you here. Now remember I said you use the initial power to multiply the variable or the constant beside the variable. Now in this case the initial power is 3. So I bring down the 3 to multiply this 3t. Okay? I bring down the 3 to multiply this 3t. So I have 3 multiplying 3t. Okay? Now I reduce the power by 1. What's the power? 3 minus 1. Did you get that? I bring the power to multiply the variable, that's 3t. Then I reduce the power by 1, 3 minus 1. Now that's for this. Then I move to the next. 2t squared. I bring down this power 2 to multiply the variable, which is 2t. So 2 multiplying 2t. Then I reduce the power by 1, 2 minus 1. Are we together? Then minus 7t. Now 7t simply means 7t raised to power 1. Now I use this 1 to multiply the variable. That is 1